We have a brand new problem this time, folks, that has to do with the calculation of power, knowing voltage and current. Let's draw this circuit first. We have an element A. We call loosely an element, which could be some device, maybe a load, maybe a battery. In general, they're just called element. This is B, and here we have C. You will notice that we have a circle and two rectangles. As we draw this circuit, we may not mean much, but at the end of this problem, we will recognize a circle in general is a supplier of energy, and the rectangles are the takers, maybe load as we commonly call them. We have 8 volt here across the element A. We have, now watch this thing, there's a minus here, there's a plus here, and here's a minus 2 volt, okay? Plus and minus 6 volt. So this current is here, and an amount of minus 2 amp, 2 amp going here, these have to be continuous though, 2 amp here, okay, and 2 amp going along this direction. So let me repeat it. 2 amp going through this minus polarity of this circle, across which we have 8 volt. 2 amp going to this device shown as a rectangle. The entering polarity is a minus. This one is plus, but it's got a minus 2 volt again underneath, as shown as 6 volt across element C. There are a lot of this minus plus thrown every which way. So if we think about this clearly, we can redraw this circuit in this manner. Let's try to make it without unneeded reversal of polarities. So if we draw this a little cleaner, what we notice is we have A and B and C. 2 amp is going through minus end of the device A, which has a voltage of 8 volt. This is 2 amp. Now notice that this 2 amp continues to go through this wire. Here we have a minus on the top, a minus. So basically this is a plus and this is minus. Double negative is what is going on. 2 volt. And a minus 2 amp going up primarily means 2 amp continuing going down. This is plus and this is minus 6 volt. So in this manner, we see that we have simplified the given set of information without unnecessary twists. Now we have to determine the powers associated with A and associated with B and associated with C, okay? And remember, power is given by the product of voltage and current. So we would see piece of A equals voltage associated is 8 volt, current is 2 amp. So here is a product. The next thing we have to notice is the fact that this current 2 amp is going through the negative polarity, minus 8, right? So we will stick this minus sign here. And as we multiply, 8 times 2 is 16, so it's minus 16. Volt 10 times amp is watt, after James Watt, that is. P sub B, in like manner, is the voltage associated is 2 volt, and the current is 2 amp. And this time notice that the current is going through the positive polarity of the device B. So there's a plus on the front of this 2 volt. So we end up finding 2 times 2, that is 4. volt times amp happens to be watt. Okay. How about the power associated with C? Once again, the voltage is 6 volt, current is 2 amp. So as we multiply 6 and 2, that's a 12. And again, this time, as we say, the current 2 amp is going through the plus polarity of the device C. So we have simply plus on the front. So if we add all these powers, we have summation P observed, as we said, is P sub A plus P sub B plus P sub C is minus 16 plus 4 plus 12. All of them are watt, of course, equals 0, meaning the power is balanced. Now, using passive sign convention, which is the US standard, the negative sign with the power means this is the power supplied. The positive signs like P sub B and P sub C mean they are power consumers. And this is called the passive sign convention, which is the US standard. So going with the standard, what we conclude is we have 16 watt as a power supplied by the circular object, which is a power supplier. And we have two loads, maybe a light bulb, coffee pot, what have you. So they take away 4 watt and 12 watt. So the total power consumed of 4 plus 12, that's 16 watts. And the power supplied is also 16 watt. So the power conservation simply tells us whatever power is supplied is taken. And there's a balance. Of course, we're assuming that this is the ideal system. No power is lost in between. So what we see here is that the total power supplied is equal to sum of the power consumed. And that is the moral of this problem. Okay, so I hope you enjoyed this. I had a wonderful time explaining this problem. So much for today. Have a good day.